All right. Today we'll be going over how to use the CNC lathe. I'm currently working with a couple people here, so if I don't look at the camera, that's why. Yeah. All right, let's get started. So, the first thing, how to power up the CNC. Well, the first thing, make sure you have your safety gear. So, safety glasses. You want to have, sleeves rolled up, hair tied back. You don't want anything on your wrist. So, like this mask, we don't want on our wrist. This watch, we don't want on our wrist. The reason is, when the lathe is rotating, you don't want anything to get caught that can suck you in, pull you in, and cause you to crash. There was a student at, I think, the University of Pennsylvania that died due to machining on a lathe late at night with no buddy. I think her hair got caught, she got sucked in, and they found her bleeding all over the shop space the next morning. So it's pretty serious. Like, it's a dangerous machine, Be careful. So anyways, now that we went through that, to power it up, over here on the side, there's going to be a switch, just right here on the back. So you're going to flick that on, and then it'll go ahead and boot up. Couple things to note. This is just to cover up your spindle. CNC programs will issue a warning if this hasn't been seated properly so that you can close it up. Believe you can override that. Yeah, you can. But it'll let you know that it's not set up right. There's a light over here in case you need additional lighting, but you should be okay. So once you have it booted up, you'll first hit check system. Once it's ready for you to check the system, just give it a couple seconds. So check system. You'll enter your max spindle RPM. The max spindle RPM is 2,500 on this machine. And you'll just hit absolute set. Okay, and from here you can start to use the machine. So I'm going to stand on this side because it shows all the buttons. A couple of things I want to highlight. This is the e-stop. Okay, so whenever you're running a program that you're a little worried about, you should keep your hand on the e-stop, or just be ready in case of anything. This system, you can go back to shut down to change anything in your system. Help button if you need help, back to go back. And all of these buttons we'll be using later on. So a couple things to talk about, the current setups we have. So DRO, that's digital readout. This basically allows you to use the CNC lathe similar to a manual lathe, where you can just control what you're running and see where your position is. So it will, whenever you open it up, I believe it'll always set to 0, 0, and then you can hand jog it using these two handles. Using these two handles, right? So where this handle controls the Z and this handle controls the X. Okay, I'm gonna set this back up here because it's not super important. So as you can see on the screen, if I use the left handle, it'll adjust my Z-axis. The Z-axis being the axis that's concentric with the part. So if you're facing the machine moving left to right, and then the X-axis being along the diameter, just forward and back. You also have this knob in between the two handles, which you can move left, right, and up and down to either move the tool holder left, right, or inward and outward along the diameter. You also have a button over here, this F-C button. So this allows you to switch between.
Do I need to be trained to use like a pencil?
Yeah.
I do?
Yeah. You need to find someone who's approved that can help you with it, and you can buddy them.
Yeah, because I want to cut my knees off. So.
Yeah, you can. Or use a Dremel or something after.
I can use a Dremel too. Where are they?
I'm not sure. So you can switch between fine and coarse over here. If you couldn't guess, fine is for fine movements, coarse is for coarse movements. So the machine will move a lot faster when you're running coarse. Then a couple things we have to do. So if we're going to run a program, which is the process we'll go through now, the first thing you have to do is put your stock into your machine. So you're going to use your chuck key for the spindle, and that'll fit right in. Oh, wrong one. There are two. So one fits into the 3-jaw, and the other one fits into the jaw clamps, the jaw holders. So if you're gonna swap the jaws out, that's when you'll use the other chuck key. I think it's called a chuck key. So this will allow you to loosen and tighten up. So we'll loosen it such that we can fit our stock in. I'll return, go back to the arrow. So I just hit a servo fault from going too far back. The servo fault is pretty good coming towards you. You can crash going the other way, so you might just want to be careful of that. But anyways, we'll go ahead and stop. We're going to be making some spacers, like I mentioned. So we'll set this into place. Yeah, we'll just go ahead and lower this into place. Now, the 3-jaw, all 3 jaws move synchronously, so you don't have to worry about tightening each one at a time, which is pretty nice. However, it's never going to be perfectly concentric, so you'll always have to turn down the outer diameter to get it just right. So you're going to get this decently tight. You want it to be pretty snug. And then, so we have it pretty snug. You always want to make sure you have a good amount of stock engaged. And you also, in general, you want to be cautious of how much stock you have sticking out, because the longer your stock is that you're machining, the higher the loads are going to be machining the end of it, right? So if you're running, a really thin tube that's very long, and you go and try to turn the outside, chances are you'll break something. So just be cautious of that. It's the principles. The machining principles are fairly similar to a manual lathe, which hopefully you have experience with if you're using this machine. But anyways, a couple other things I want to mention. So the accessory button engages the coolant, and there's also an orange knob right here to basically just to allow coolant to flow. So you can turn this on to start up the pump, and then you can open this up and you'll start getting coolant out. And you want your coolant running over your tools, usually when you're doing some CNC ops. When we're doing zeroing and pretty simple stuff, I typically won't worry about it. So we have our stocking, okay, and we want to machine it, right? So the first thing that we need to do, particularly for the CNC, is we need to set our 0 position, right? So do you know how many axes there are that we need to be concerned with? 2, yeah. Do you know which ones they are? Yep. Yeah, and the X, right? So the Z-axis and the X, which are the 2 that we have to zero. So the first axis that we'll zero will be the X, because that one's easier. And the way we'll do that is we'll go ahead and put a tool in. So to put a tool in, here we have one of our tools, right? Insert. And then this dovetail fits right over the dovetail that we have here, okay? I wish I could swap the camera. So here we have a dovetail which fits right onto the tool holder, and this is the loosened position, this is the tightened position. So we'll loosen it up, put it on here, ensure the surfaces are clean, and then we'll just clamp it right in. Something you typically want to check is that your tool is true. So you can put a dial indicator onto this surface and just check your tool. I'm not particularly concerned about it at the moment because no one's really been messing with this, and it should run true. But that's an issue to take note of particularly if you're machining like high precision, high tolerance parts. And if this were out of true, what you would do is loosen this nut, and that would allow you to tap this into place with a mallet until you see that there's no significant deflection along the entire surface of the tool, right? That would tell you that you're perpendicular to the z-axis. But like I said, we're not going to worry about it right now. It takes a while, and I think it's fine. And we've made a bunch of parts already. We should be good. So now the next thing we'll do is we're going to want to come in, and you do not want to make contact with the stock unless your part is rotating, because you will very easily break your insert. So we're gonna about line it up so that we can take a cut going all the way down. We'll just do one pass along the entire face, and we'll set that as our Z0. Okay. Something important to note, Candace, if we can go back to this screen. Something important to note is what tool number you're running. So the machine automatically goes to tool 1. For high tech, okay, our tools start at tool 80 and run forward from that. The reason our tools start at tool 80 is because all of the tool zeros, like the relative zero positions, are saved in the machine. So because we have set up tools 80 to 100 based on our tools, by zeroing tool 80, we know all of the other tools should be zeroed because the relative positions are set up. Okay. The reason we start at tool 80 is because when you load up the machine, it automatically sets at 1. So anybody else who's using the machine will typically use tools 1 through 5 or 1 through 2 or whatever, and they'll zero each tool individually. We don't want to have to do that because a lot of our parts require multiple tools to complete the operations. So we have it all set up from 80 onward. If you're not on high tech and you're watching this video, please don't edit any tools that are 80 and up. Please don't use tool numbers 80 and up when you're running your programs. Yeah, please don't do that because it'll cause a lot of pain. So we're gonna go to tool 80. All right, now we're in tool 80. Oh, another cool thing, you can really easily change between inches and millimeters using that button, which I personally like a lot. So we'll go to fine. We'll spin it up and we will run, I'm trying to remember what we ran before. Typically you want to check what the recommended feed rate is, and feed rate and RPM. You can't really set a feed rate when you're running manually, you just have to eyeball it. But the RPM or SFM you should probably look up. From doing this before, I believe we did 2000 RPM and we're good. So when you're running this machine, you can use incremental set to set RPM, absolute set to set in SFM. SFM goes based off the surface feet per minute, which means your RPM will change as you change your diameter. RPM is constant. Typically you want SFM when you're running passes along the diameter, but since we're taking off a really light shaving, it's not a big deal. In our cam, we do have it set to SFM based on what the manufacturer recommends, or what the tool manufacturer recommends for the best finish. So that is all pre-programmed in HSM Works, and you'll see it set up when we look at our what's the word, G code? Yeah. So we'll set this to RPM, and then we're gonna go ahead and start it. So you can set the spindle to forward or reverse. If you're cutting, you always want the spindle to spin inwards towards the tool. So if you're cutting on this side of the machine, you would want it to spin forward, which is coming this way. If you're on this back side of the machine, you'd want it to spin reverse, okay? Can you think of any reason why you would cut along a different side of the machine? Threads, right, or left-hand threads. Another reason, this boring bar, for example. If we had to zero this boring bar ourselves, because let's say our tool references got messed up and we had to redo all of them, the boring bar sits, you know, on this part of the dovetail, and clearly you can't machine from the side closest to you, so you actually have to machine from the back, right? So if you were going to zero in this case, you would want it to go in reverse. Okay, so we will go ahead and set spindle forward. Spinning up, looks pretty good. So we're gonna come in, make sure this is all good. We're just gonna check to see if we're making contact. And I just want to take a hair off. Looks like we're making contact. And we'll feed it down. So we'll set our Z to 0, absolute set to override the Z, and we can bring it back out. So we're clear. You do not want to stop. Okay, now we can stop. And we'll hit stop. Oh, sorry, we'll hit off. So, a couple things. You don't want to leave the tool sitting on a rotating part because it'll cause to rub and cause a lot of heat. You also don't want to stop spinning the stock while the tool is making contact because it'll heat up and it'll slow down, and that combination can lead to friction welding of the tool insert and the part, which now ruins your part. You know, if you have to hit the e-stop because of some emergency, then obviously safety first. But in general, you don't want to. So we got a pretty good finish off here, and now we have referenced our Z0. The next thing we need to do is set our diameter. So what we're going to do is take some light passes off the diameter, right? And then we'll measure that, set it in the machine, and that'll tell our machine where the center line of the part is. Okay? So, similar process. We'll go ahead and spin it up. And you can tell just by looking at how it spins that it's a good bit eccentric. So, out of true. I'm just gonna go forward until I'm getting a hair off. There's a couple ways you can do this. So you can feed into the stock until you see that you make contact, come out, dig in a bit more, and come all the way across. Or you can come down until you see yourself making contact and then run all the way across. You can't use the X position here. The Z position only tells you, so the Z position doesn't tell you when you're going to make contact along the diameter, right? Like if the tool is here, it doesn't matter what your Z is, you're not going to touch it. Yeah. So that doesn't tell you much in this case. I'm just going to keep going forward. I find this is a little faster. I'll take a little bit more, and now I'll come across, and I'll take a good chunk so that we can measure it. Oh wait. Alright. Come back out. And turn this off. And I'll check to see if the finish is alright. It's not great. I'm going to take another shaving off. I think I just came out a little too far. Well, what I'm going to do, because the finish tends to get a little messed up from the rubbing, is I'll come to a known X position. So let's say 16. Okay. And then I'll come across at 16, back it out, we'll measure it, and then we'll go back to 16 and reset to whatever we measured to, right? So spindle forward, and then I'll go ahead and come across. That might have been a little too light. I think I'll do 15 and a half. 15. There we go. Now full cross. That seems better. Alright. Turn it off. So a couple important things to check. One is that you're actually turning across the entire surface. So if it's really concentric and your cut isn't deep enough, you will basically see parts of it still have the raw stock showing. Okay. And then now we'll measure it. We'll set our position back to 15.5, and we'll reset it. So we'll go get the micrometers and then come back and check that. You can solve it. So what we're going to do is we're going to measure the diameter using micrometers. The way micrometers work is they're very accurate measuring devices. I guess that doesn't explain how they work, but you know, you just turn it and you read the micrometer. There is a smaller grip, I guess you could call it, which has a very slight torque set, so it'll start to click once there's a certain amount, a very small amount of preload, and that'll help you find the exact position. So what we'll do is come into here. Well, I need to loosen it a bit more. Alright, that should be good. Make sure you have the micrometer that fits the right size. So you want to get the outer diameter, and so what I'll do is come in until it's tightened, and when I pull it out, I'll just make sure that I came over the diameter. So that should be good, and then I'll measure this. Well, I'll just read this. So these numbers are, the top lines are millimeters, the bottom lines are half millimeters, and then you can read off the dial. So looking at this, we have 21, 22, 23, and then I believe that's 24 millimeters, 0.01, right? Yeah. So 24.01 is what I got. You guys can both go and check. You can stop the video for now.
Mm-hmm.
Okay. So we found that our diameter is 24.01. So to set it, we're going to set X. 24.01 absolute set. It's important to note that the X-axis is set based on the diameter, not the radius. And if you ever forget, a really good way to check, which I tend to do, is now that I have my X and Z zeroed, I'll go ahead and come to the X0. I'll come to the X0, and I'll just see visually if it looks about lined up with the center line of the stock, and it does. And then I'll back this out, and I'll bring it over to the Z0, and I'll see if that looks about lined up, and it seems about lined up, so we're good. The next thing I'm going to do is double check the rest of my tools, which should all be good to go. But I'll put each tool in, change my tool number to whatever tool I have, and check that it's zeroed. If you know you didn't have tool references set up, the way you would do this is you'd go to mode, you'd go to setup, you go to tool setup, and you would enter each tool, zero it the way we just did, and then save all your tools after. And that would override all whatever tool numbers you're using to the new references that you set, right? So you could set like tool number 1, for example, absolute set, you know, edit or set new, and you can change all of your positions. This gives you whatever readout it has. So yeah, you would just zero all of your tools using this, what's the word? This window, I think is the right word to use. And then after you're done, you would hit save tools, okay? Our tools should all be referencing tool 80, which means all we had to do was zero tool 80, and we should be good to go. If another team's watching this, you know, if you want to reserve other tool numbers between 1 and 79, feel free. Yeah. But usually people on here are only using 1 or 2 tools, so if you're only using one, you can just set that one tool and you'll be good to go if you're only using a couple. you know, you can edit those too. So now we're gonna put the rest of our tools in. I think this is tool 86. We'll find out. So we'll go back to mode. So yeah, the setup is where you can set up your tools as well as some other things which we'll get into later. Hero. Change my tool number to 86. And then I'm going to check the Z0. Okay, it's definitely not tool 86. Let me change the tool number to 96. Nope, let me change the tool number to 97.
I think it was 8. I do.
87. What the heck? Alright, hold on.
I think the parting code was 98 or something like that.
Yeah, I'll check the cam now if it isn't, or if I can't figure it out. Tool, let me just make sure this is still 0. What? It seems like it. Yeah, this is still zeroed up. So, let me go back to here. Oh, you can stop it.
Yeah.
Okay, so really quick, I just want to explain how to drill on this machine. So, we have a drill chuck, right? And this lies on some linear rails. So I don't know what this is doing here. There's a clamp here that allows you to, you know, engage or disengage the clamp. And then you can see this slides forward and back. And then you can also move it using this crank. And so if you wanted to drill out some stock to make space for a boring bar or something like that, this is what you would use. If you wanted to replace this like drill bit chuck with a different one, you would just back this all the way out until it was unseated, and then you can pull it out, seat the next one in, you know, put it in, and you should be good to go. So something to note is that this clamp tends to be pretty loose, and so whenever I am drilling on this machine, I like to have one person just engaging the clamp while I am feeding the bit in. And with drill bits, you tend to want to run a lower RPM than when you're running any of our tools. So typically around like 8 to 1200 RPM for drill bits. I think you tend to go lower if the drill bit is larger. Don't quote me on that though. I'm not an expert machinist. You know, look into feeds and speeds yourself. So yeah, we'll drill that out, and then we'll move on to start the actual cam operation. You can stop. Ready?
Mm-hmm.
Cool. So we've zeroed our tools. We've got our stock ready. The next thing to do is to upload our cam. So that'll typically be some sort of G-code file, which you've done probably on HSMWorks. We're going to go ahead and put our USB into the port on the back here. We'll go back to mode. We will go to, well, actually, let me go to DRO. Let me set my tool number back to tool 80, just because that's what we start at. Okay. We'll go to our mode. We will go to program in out. List supported programs only, yes. Let's set to yes, so we're good. Then we'll hit open. So this is looking into the D drive. That's the flash drive that I plugged in. You can use these to go like, you know, up and down. Basically functions like an old Windows unit. So data forward, 123 cam is the cam for this part that we're making. I'm gonna hit open file. Cool. So the file has been opened. You'll notice the run tab is still grayed out. It's not letting us select it. You might be wondering why. The reason is we haven't finished setting up everything. So there is one more thing we have to set up. So if we go to setup, we need to set up our reference position, okay? And the reference position is the position that the machine will go to in between tool changes, right? So since we're changing the tools ourselves, it'll go to this position, shut everything down, allow us to change tools. And we want to set this position to a position that we know is very safe. So we basically just want it to be like pretty far from wherever we're machining, okay? So for this part, we're gonna set our X home to 50 and our Z home to 50. This is in millimeters, as you can see by our units. And this is with reference to the home position, which is at the center along this surface, right? Depending on your part and your tools and whatever, you may want to make this higher or lower or whatever. I've made this before. 50 is good for the bearing cups. So we'll set that up. We don't need to worry about our limits in this case, but if you wanted to set some sort of like X or Z limit for where your tools can go, you can do that. And then we'll hit return. We will double check that it was set properly. It was, we're good. The next thing I think we can do is go to tool path. So this will show you what cam you have loaded, okay? This shows you the tool path that the tool is gonna follow. So as you can see here, we have a couple things that are going on. The first thing, which we have going on, is a few turning passes to get the outer diameter of the bearing cup. Then we have a couple boring bar passes to get the inner diameter. And then we have this straight line, which you can see here going all the way down, which is our parting tool to part off, okay? I know the order. If you don't know the order and before you're running a program, I recommend stepping through. So you just hit step and you can go through each event, right? So each event is gonna be a move and you can press in between each of these to make sure it's right, or you can press and hold and it'll fast forward through them. Okay. And then you can go through here and you can see all of your paths and just make sure that it looks accurate. You check your position. This is your reference position that I was talking about. Make sure it looks like it's reasonably far away. This all looks good. So we'll go back to our mode. Now the run is enabled, which means we can actually run this and start doing some cam operations, okay? Or start doing some CNC operations. So we're going to hit run. Door guard open, it will give you that warning when the door guard is open. You can still run it with the door guard open. That warning will just exist. For safety reasons, you may want to keep the door guard closed, but also sometimes you have to like get a good peek in there. So I would just say like kind of hold this if you're looking at it or whatever, keep an eye on it when you're doing risky programs. Always have someone ready for the e-stop. Wear your safety glasses. So what we're gonna do, there are two starts. You can hit start or start at event number. If, for example, you wanted to repeat an event, you would want to start at whatever event number you're starting at. If, something went wrong and you changed tools and for whatever reason, you only wanted to do part of your program, you would hit start at event number to do that part of the program. So we're gonna start from the beginning. So we're gonna hit start. It's gonna say, are you sure your tools are set properly? We did check those, so we're sure. We're gonna hit resume. Okay, now there are a couple would you call this a dialogue? I think you would, right? Display, dialogue, whatever, that you can select. So this is just showing a digital readout of your position. I like to go to show path. There's also show program, which will show you each of your steps, okay? So these are the actual events in your program and it's telling you what's being set. So for example, in this event, I believe this is a turning event. Okay, whatever. I believe this is a turning event. You can see it's at the surface speed, what I was talking about earlier, right? Because when you're, doing certain passes, you want surface speed as opposed to RPM itself. Anyways, I like to go to show path because it'll tell me what's going on, where the tool is going, and I can sort of get an idea of what's going to happen before it does. The next thing I like to do, so you see it says start spindle, press go for CNC run or press tracking. CNC run means the machine will just follow your events and run completely on its own, okay? Tracking allows you to control its path, so control its feed using this handle. I always like to do tracking on my first run just to make sure everything is good. Because, if I'm cranking it and I see that it's about to crash, I can stop it before anything happens. Whereas if you hit CNC run and it just starts going straight at the part and it's about to collide, you're kind of screwed. You have to make sure you like press stop or hit the E-stop quickly enough. Okay. So I always like to do tracking first, which is what we'll do. So we'll hit tracking, and then I believe we can crank it. Yeah. So if you come over to this side, well, you'll see here, it's moving to the reference position, which is that X. That's where it wants to go, right? Okay. So now it's going to say load tool 80, start spindle, press go for CNC run. We're currently set to tracking, so we'll be good. So we're going to insert our tool. We're going to insert our tool. Okay. We're gonna set our coolant position. So you want the coolant to flow right over the tip of the tool that's doing all the cutting. So I'll set my coolant on and then flick this. That seems pretty good to me. I'll set that off. Always remember to turn it on before you start. You can also set this to auto, which means it'll just turn on whenever you're running it. CNC command. I personally do it manually. It's really up to you. Anyways, we're going to start our spindle. So press forward because that's the direction we want to go in. And then we'll hit go, and it should not do a CNC run. Cool. You'll notice we're getting a spindle RPM out of range error. This is because the machine is not capable of hitting the RPMs that our inserts want. These inserts are meant to run at like insanely high RPMs. They're meant to take a lot of load. We can't do anything about that. You know, if someone wants to get us like a really good CNC lathe, that'd be awesome. I'm not the biggest fan of this machine, but it gets the job done. So we're gonna turn on our coolant, and then we're gonna start cranking this. And we'll always want to have somebody ready to hit the E-stop in case of an emergency. So I'll go ahead, keep my hand here on the E-stop. And then I'm just keeping an eye. It's already telling me, you know, what's going to happen next, right? Which is why I love having the show path on. I can already see what's going on. And I can kind of eyeball it and say like, oh, does this look like what I programmed it to do? Which, so far, yes. So, now I'm going to come in. The first pass shouldn't make any contact because the stock diameter that I set was slightly higher than the diameter we have. That's kind of like a safety measure. And then we should be getting some contact soon. There we go. So now it's making contact. And now it's going to go to the home position, and it's going to say to load tool 96. So we're going to move on to the boring operation at this point. So I'm going to turn the spindle off, turn the coolant off, so that I can come in and take a look at my part. I think the finish is good. Left some pieces here on the edge for whatever reason. What I'm going to want to do here is take a measurement, either using calipers or micrometers, depending on how precise your tolerance is, and just make sure that this is accurate. If it's inaccurate, there are two ways I can adjust this. I can either adjust the tool profile, right, back in our, in our setup, or I can go back to the cam, change the stock to leave, right? You don't want to change the actual part, it's bad practice, but you could always change the stock to leave to check what's going on. So we'll go ahead and measure this with some calipers.
Yeah.
Okay. So the next operation we're going to do, I should turn this off, is a boring operation. So this is when we're milling at returning an internal profile. A couple of things to keep in mind. You really want to make sure you have enough space for your boring bar, which we've checked quite a few times. It's pretty tight, but it should fit. And you know, on the first operation, you want to go slow and just check that you're not going to crash, because you never know if you screw something up in your cam or something of that sort. So yeah, just keep those things in mind whenever you're running these. We're again, like the last operation, we're gonna hit tracking, and then we'll hand feed it the whole way through. And then once we're done with this, we will use some telescoping gauges to measure the internal diameter and make sure it's within spec. Assuming it's out of spec, which it most likely will be, we'll change our modifiers on the tool itself and then save it under new modifiers. The reason we use different modifiers is because as the tool, you know, runs different operations, it wears down, and so you need to adjust whatever the true zero position is relative to all the other tools. And we typically do that every time we use the machine, because they'll, you know, get worn out by just a bit, which can make your diameters off by 0.05 mils or 0.1 millimeters or whatever. So yeah, we put in our boring bar, we adjusted our coolant, and we should be ready to give it a shot. So we still have tracking. Spindle forward. There we go. And then you can see on the toolpath, it's showing the internal boring profile. So this is the scariest operation to do because it's the most likely to result in breaking something. Doesn't sound great either, but this finishing pass should sound a lot better. Also keep in mind, you know, the feed rate isn't what it should be because I'm feeding by hand, which affects the finish and the sound. Okay, so we're done with this. Our last operation will be to part it off, but before we do that, we're going to go ahead and check that internal diameter and make sure it's good. Okay, Alright, so the next step we have, this is the final part of our, like the final operation that we have, which is the parting knob. So yeah, so we need to part the tool, or part the part, which is just to take it off of the sock so that we can actually use it. And for that, we'll use a parting tool. This is what a parting tool looks like. Pretty straightforward. It's important to check when you're setting up your cam and when you're running this, to look at where your offsets are on your parting tool. So for example, if you were cutting with a, like, you know, left side offset, it would set the 0 based on the left corner. If you're cutting with the right side offset, it set the 0 based on the right corner. It's also important to account for this when you're setting up your cam. So for example, you know, if you're setting your tool to part at 6 millimeters, right, and our parting tool has a width of 2.65 in this case, that means that our parting tool is going to remove material all the way up to 8.65 millimeters into the stock, right? So when we turned this, we actually turned away 9 millimeters. That way our parting tool would be free all the way until it got to the bearing cup itself. Just because, you know, I don't need the parting tool to be cutting all of this extra material. It's just gonna wear the tool down unnecessarily. So that's the idea here, right? It's a good thing to keep in mind whenever you're cleaning. Again, we'll set our coolant. Right. That seems good enough. And then we'll go ahead and run this tracking. Spindle forward, press go. done. Before we stop, let me turn this off. So our part is down here. After this, you'll want to check the width to make sure it's good. A couple things to note, this parting operation left a burr, which may need to be accounted for on the next stop, just something you'll want to deburr afterwards. When you're done with the machine, make sure you clean out the bin with chips, and you put the chips in the respective bucket. So we're machining steel, which means we'll put it in the red bucket, the red bin. And then you'll want to reset your 0 position to run the next operation if you're going to make this part over and over again. Now that we've kind of validated the process, I and you could feel comfortable to just run it as a CNC op. I'm trying to think if there's anything else. Oh yeah, so one more thing I want to mention is if we found that we needed to change our modifier, what we would do is we would go to setup, tool setup, we would choose the tool. So let's say, for example, we're changing tool, what was it, 98, absolute set. We can hit edit, and then we can adjust these modifiers here, right? So this X shows us what our current X position is, and let's say like 79.6 in the system was 78 in reality, then we would set our X modifier to be, instead of 0.1, we would increase it by 0.4, right? So we would set it to 0.5 or negative 0.5. I always forget which way to go, but you can just guess and check and see if it lines up. So yeah, that's what you would do if you needed to change your modifier to get your parts within tolerance. That's about it. If you're gonna shut the tool down, so let's assume we're done, you would go to System, and then shut down. You would wait until it says it's safe to turn off your computer, and you would flick the switch. And yeah, that's all I have. There are feeds and speeds overrides, so if you wanted to bump it up or down, you could do that while it's running an operation. What else? You can go into program and look into your program, go to the beginning. You can go look through the events. You can change your data point if you wanted to edit something. Yeah, that's pretty much the basics for using this machine. Should be good enough to get you guys started. So now you guys are going to go ahead and give this a shot.